Assalamu alaikum. In this video, we will learn the sum of the term of given arithmetic sequence or arithmetic series. These are the formulas we can use to find the sum of n terms of a given arithmetic progression. Here, Sn is equal to sum of first n terms, n is equal to number of terms, a1 which is equal to first term, and an which is equal to nth term or last term. D is the common difference. Now take one example. Find the sum of the first 20 terms of the arithmetic sequence 4, 7, 10, 13 and so on. Here a1 first term is 4, a1 which is equal to 4, and the difference between two consecutive terms d is equal to 3. N is equal to number of terms, it is given n is equal to 20. Now we have formula Sn is equal to n by 2 into 2a plus of n minus 1 into d. Now substitute the values which are given. S20. In place of n we substitute 20. 20 by 2 into 2 into a means 4, plus n once again 20 minus 1 into d which is equal to 3. Now solve. S20 is equal to 20 by 2 10, 2 into 4 which is equal to 8, plus 20 minus 1 which is equal to 19 into 3. S20 is equal to 10 into 8 plus 19 into 3, 57. S20 which is equal to 10 into 8 plus 57 which is equal to 65. Now if we multiply 10 into 65 we will get the answer 650. Therefore S20 is equal to 650. Let's take another example. In this question, the first term of the arithmetic sequence is 5 and the 11th term is 35. What is the sum of the first 11 terms? Here given first term is equal to 5, a1 is equal to 5, and the 11th term a11 which is equal to 35. Number of terms n is equal to 11. We have another one formula on the basis of their terms. Sn is equal to n by 2 into a1 plus an, means first term plus last term. Now substitute the value here. S11 which is equal to 11 by 2 into a1 5 plus last term or an which is equal to 35. Therefore S11 which is equal to 11 by 2 means 5.5. Now add 5 plus 35, it will get 40. Now the final answer becomes S11 is equal to 220. Here in this example we used the second formula based on their terms. Okay, next take another one example. Find the sum of multiples of 5 between 19 and 99. Multiples of 5 means those numbers which are divisible by 5. Here our first number is 20 because it is greater than 19 and under 99. So our first term is 20 just because it is divisible by 5. Next to the term is 25 and so on up to 95 because 95 is come under 99. Now sequence is ready. Here the first term a1 which is equal to 20, term an which is equal to 95, d is equal to 5 which is given. We have to find the n is equal to question mark. So we know the formula to find the n. Use formula to find the nth term. In that an is equal to a plus of n minus 1 into d. Here first term is given and last term also given, d is also given. We can easily find out the value of n. Now substitute the value of an which is equal to 95, a which is equal to 20 plus of n minus 1 into 5. 95 which is equal to 20 plus 5 into n 5n minus 5 into 1 5. 95 which is equal to 20 minus 5 which is equal to 15 plus 5n. Now shift 15, we will get 95 minus 15 which is equal to 80. 80 is equal to 5n. Now divide both sides by 5, we will get 80 divided by 5 is equal to 5n by 5. Here 5 get cancelled. N is equal to 80 by 5 which is equal to 16. Now our actual question is to find the sum of multiples of 5 between 19 and 99. So we have found just value of n. Now we have to substitute the value of n in this formula. Sn is equal to n by 2 into a1 plus an. S16 means n is equal to 16 which is equal to 16 by 2 into 20 plus 95. S16 which is equal to 16 by 2, 8 into 20 plus 95, 115. Now multiply 8 and 115, we will get 920. Therefore, the value of S16 is equal to 920. Let us evaluate summation of 3i minus 1 where I goes from 5 to 16. This is an example for sigma notation or summation notation. This is the symbol of sigma. It means that we need to find the sum of 3i minus 1 where I goes from 5 to 16. Since I goes from 5 to 16, we need to substitute the value from 5 to 16 in place of I. I is equal to 5, 3i minus 1 which becomes 3 into 5 minus 1 which is equal to 15 minus 1 which is equal to 14. Therefore, a1 is equal to 14. 14 is our first term. Next, I is equal to 6. 3 into 6 minus 1 which is equal to 18 minus 1 which is equal to 17. A2 is equal to 17. This is the second term of our series. To find the last term of the series, let I is equal to 16. Now substitute the value of I is equal to 16. If we substitute 3 into 16 minus 1 which is equal to 48 minus 1 which is equal to 47. This is the last term of our series. An is equal to 47. After solving the sum of the term of the series, we have 14, 17 and so on up to 47. We need to find the sum of these terms. The first term is equal to 14 and the last term is equal to 47. Let us find the value of n. Since I goes from 5 to 16, we can easily determine n is equal to 12. Let us now find the sum by using formula Sn is equal to n by 2 into first term plus last term. Sn is equal to n by 2 into a1 plus an. S12 is equal to 12 by 2 into 14 plus 47. S12 which is equal to 12 by 2 is 6. 14 plus 47 is 61. Now multiply 6 into 61. We get S12 is equal to 366. That is what our final answer. Thanks for watching. Subscribe for more videos.